Hello, friends. Good evening once again. Welcome once again to another episode of Manthan. In these series of episodes, we will discuss a bit about these are the three questions that we will be discussing about. The first one is the gravitational waves. Gravitational waves are known as those waves which are generated when cataclysmic incidents like neutron star merger or a black hole merger occurs. These are most violent incidents happening. So when we say they are violent, we generally relate it to explosion. And we know that when it is black hole, explosion is a no-go. Explosion means the mass moving away from the center, which is not allowed. So this merger will have to be a silent merger. So this is a contradiction. How can a silent merger give rise to shock waves where the space itself gets stretched and the gravitational waves are generated? This is what we are going to study. And the next contradiction is appearance of supermassive black holes in the early universe. Generally, when star dies, a black hole is born and then it keeps on feeding, becomes bigger and bigger to the extent of becoming a supermassive black hole. And we see these generally supermassive black holes in the center of almost all the galaxies that we see. So it was generally thought out that when you look up into the sky and you see these supermassive black holes, it's okay for them to be as big as they are now, because supermassive black holes are to the extent of 4 million solar masses. But when you look back into time, which is early universe, we were under the impression that these supermassive black holes would not have formed then. But unfortunately, exactly the evidence to the contrary happened, which is supermassive black holes were found very early into the early universe. So we are going to find why this contradiction. How can supermassive black holes form in the early universe? And the last question is, when you look up into the sky, you see stars, you see galaxies. When you see stars, you see two types of them. One is young, another is old. So stars have been forming from time immemorial, from early universe, ancient universe till now. Even now it could be stars are forming. But when you look up into the sky and look at these galaxies, you would not see any young galaxy. All the galaxies that you would see would be fairly old. In the sense, all these galaxies were formed when the universe was still in its infancy. So we need to find out what are these conditions, why the galaxies, when you look up into the sky, why don't you see a galaxy forming the way it was formed earlier? Because galaxies need gas, there are interstellar gases. So how is it that the conditions are not conducive in the contemporary universe? What were the conditions which were conducive for galaxy formation in the early universe? So let's start with gravitational waves. So we said that this universe is a very violent place. So you have all kinds of violent incidents happening, binary stars merging into each other, neutron stars, quasars. You got supermassive black holes at the center of the almost all the galaxies, black holes feeding. So, but the worst kind of a cataclysmic, when you look at the scale of cataclysm, the worst that one could find out is two black holes merging. This is so violent and so powerful that the space itself gets stretched. And when that space gets stretched, there are waves created in the space itself, and we know those waves generated as gravitational waves. So generally, when we talk about violent incidents, we think that they are explosive in nature. And generally, when you say explosive, that means the mass is moving away from the center, which is not allowed in black hole. That means whatever this merger is happening has got to be a very silent merger. So if at all they are supposed to be silent, how is it that they can create an extreme wave like a gravitational waves? So before we go on to the gravitational waves, let us study how the black hole merger happens itself. If you remember the previous time when we are studying why black hole cores do not explode, we said that it is because the nature of the core, the size, the volume, the temperature, weight does not change at all. Despite all the mass which is falling into the black hole throughout its life for millions and billions of years, because all that mass would have never reached the core itself. That is because black hole being a very dense, extremely dense mass, it affects time around it to such an extent that the time near the core of the black hole would stop. So in the sense, all the mass is not coming and reaching, and hence the core shape does not change and it is not going to explode. If that is the case, then how two black holes can merge? The other black hole is also just a mass. So we had said earlier that everything that reaches the core is not able to reach the core finally. It just goes there and stands still as though time has stopped. So we need to find out what are the reasons why two black holes eventually merge, because what we see is these black holes merging. So what are the difference between these two? The first one that we talked about, when the core is not changing, the general size and shape the core, is because on one side it's a black hole and the other side is a normal mass which is trying to fall into it. Whereas in this case, it is two black holes which are trying to come together. So what happens? How different is it? So you have one black hole which is extremely dense mass. Because of that, it has got warping of the time zones around it. So in the same way, the other black hole is also an extremely dense mass, and it is also supposed to have extreme forces around it and warping of the time or slowing down of the time. So you will have time zone both here as well as here. But when they come near each other, obviously when they come near each other, you have time zones here and here. Nothing is changing because these are the forces which are acting in these directions. But look at what is happening between this head-on line of direction between the two black holes. Obviously these forces, for the sake of argument, let us say that both are similar in mass, x solar masses. It never happens in true life, but let us assume that both are x and x. So the extreme forces generated or attractional forces generated in this line is the same. So obviously they cancel out each other. So when the forces are cancelling out each other, those forces, the extreme forces, were the reason why the time zone was happening in the first place. So in a way, the black holes create a space which is head on, allowing them to come near each other. Of course, that doesn't mean that they come and slam immediately. They still do take a lot of time, millions of years to come near, because they need to negotiate the space around them. There is a dance of death which is happening between the two black holes, each going around the other. So they need to negotiate the other time zone. So that takes time. But otherwise, there still is an escape hatch where they can come near each other and then merge. Now, obviously, as the problem was when they merge, it cannot be explosive, because when you say explosive, that means the mass is moving away from the center. The black holes will never allow that. So it will have to be a silent merger. So the question was, how do these silent mergers create gravitational waves which are very difficult to create, where the space itself has to be stretched? So let us now go to that. So you consider two incidents. One, it's basically pebble dropping into a lake. Obviously, when you drop a pebble into a lake, you see these waves. But now I give you another example where you are not dropping it suddenly, but you are slowly lowering that pebble on the surface of the water. You will see that there are no waves forming. Why is that? In the first case, that is because the film of the water surface is providing the resistance to the pebble which is falling. That particular force, this one is providing the resistance. This resistance force creates a bouncing nature incident. That bouncing nature creates a wave. So we need to try and find out how this, just hold on to this thought of the bouncing parameters. So we need to see how the space, the fabric of space creates a bounce when two black holes merge. So these are those two black holes. Let us again, for the sake of discussion, consider them as exactly same, x solar mass and x solar mass. They are away from each other. So now consider a situation where they have not merged, but they have come very close to each other. Now look at what is happening on the effect of the space. The space would be stretched, let us say, I'm explaining it very crudely. Space, when this black hole on its own can stretch the place to the extent of this. Let us assume that this is x. In the same way, other one is also similar, so that can also stretch it only up to here. When they come near each other but they are not merging, that means in that space you have 2x mass. So that means the stretching will have to be twice as much as it was here. So that means it should have been here. Now assume that these were just simple dense masses and they are coming together, silently merging, and there is no explosion, and the stretching of the space would be 2x, but there is no resistance and there won't be any gravitational waves. But what is happening here? These black holes are not just simple extremely dense masses. They are extremely dense masses, but they are feverishly spinning dense masses. So when they are trying to merge, you will see that two masses which are spinning at a very, very high rotational speed smash into each other. And obviously there is an energy generated. That energy again cannot move away from the black hole. But in this process, what happens is there is an energy loss of the general two black holes. Whatever the energy that they had to begin with, there is an energy loss when they merge. So when the energy loss happens, it is manifested as the loss of mass itself. In the sense, just before merging, they are supposed to be 2x, but when they are merging, they lose that little bit of 0.8, let us say, I don't know about it, but let's say less than 2x. So imagine the space when the black holes were nearer, it was getting stretched to 2x, and suddenly at the time of merger, there is energy loss, loss of mass, and hence this stretching slips, and you have this kind of a situation which is between x and 2x. And what does this mean? Between 2x and x, there is this bouncing back, and that bouncing back is creating gravitational waves. So they are silent, they are not explosive in nature, but still it is able to generate gravitational waves because of this reason, the bounce that they get, because of the loss of energy and the manifestation into loss of mass.